For some practice with velocity, speed, and displacement, let's consider this situation here. We got lots of words. We're going to draw a diagram as we go to try and get our mind around this. So Jill sets out from her home to deliver flyers for her yard sale, traveling due east along her street lined with houses. All right, let's get the diagram here. We start from the home. We travel due east at 0.5 kilometers, and 9 minutes later she runs out of flyers and has to retrace her steps. So if we're trying to find total displacement, let's start off by defining an axis. Here the x-axis is going positive to the right. And then we'll keep track of our displacements on these different legs. So we start off with that 9-minute trip that gives us 0.5 kilometers worth of displacement in the positive x direction. All right, so she retraces her steps back to her house to get more flyers, which takes an additional 9 minutes. All right, so she goes 9 minutes in time and travels negative 0.5 kilometers in displacement. After picking up more flyers, she sets out again on the same path, continuing where she left off, and ends up 1 kilometers from her house, which takes 15 minutes. So we have a third leg that goes positive 1 kilometers of displacement. It takes 15 minutes. At this point, she turns back toward her house, heading west, and after 1.75 kilometers and 25 minutes, she stops to rest. So finally, we have 25 minutes worth of travel that end up with a displacement from where she started at the beginning of that last leg of negative 1.75 kilometers. So what's her total displacement to the point where she stops to rest? Well, you might just be able to figure this out as, well, she was at positive 1, she goes negative 1.75, so it's negative 0.75. We're going to go ahead and write this out with the equation to show that. Our total displacement is you add up the displacement from all these legs. And so plus 0.5, minus 0.5, plus 1, minus 1.75 gives us a displacement of minus 0.75 kilometers. So we could say that's a displacement of negative 0.75 kilometers in the x direction. Or, if I wanted to put this in terms of east and west here, we could say 0.75 kilometers to the west of where she started is her total displacement. All right, what's the magnitude of the final displacement? Well, magnitude doesn't care about the positives or negatives. It just cares about the magnitude, how big this number is. So you take the absolute value and you get 0.75 kilometers. What's the average velocity during her entire trip? Well, we take the distance divided by time. But keep in mind, this is not total distance because we want velocity. This is going to be displacement. So her total distance, she was traveling a bunch more, but her actual final displacement is just her final position minus her initial position. And so we have 0.75 kilometers to the west divided by the total amount of time it took her to take the trip, 58 minutes. And when we calculate that, we get 0.013 kilometers per minute to the west. Now this is a velocity, that's a vector quantity, so you always have to have a magnitude with units and a direction to the west. You could have also written this as negative 0.013 kilometers per minute in the x direction. How about the total distance traveled? Where here the total distance traveled is, rather than adding up all the displacements, we want the magnitudes of the displacements. So we'll sum up the magnitudes or the absolute values of each displacement to get the total distance. So it's going to be 0.5 plus another 0.5 because total distance, she's traveled all that distance. And so plugging all those in, they all become positive, and we get a total distance she's traveled as 3.75 kilometers. Hopefully that's clarified some of the differences between displacement here, which is final minus initial, and total distance traveled, which cares about all the motion you've done along the way to get there.